Hello, welcome. My name is Jose Blackerby. I'd like to welcome you to our breakout session called New UDL Technology Solutions for the COVID-19 Era and Beyond. I'm joined by my colleagues James Basham, Boris Goldowski, Tracy Hall, and Anne-Marie Kanoki. The opinions that we are representing today are ours and do not reflect the policies or opinions of the Department of Education. So, the COVID-19 pandemic just upended almost everything in our lives over the last 15 months. Schools were particularly hard hit, and virtually all students throughout the world had their education interrupted and disrupted, and we were very, very unprepared for what we were going to need to do. And the outcomes of that experience are many multifold. We know that many students did not have the opportunity to learn that they had in the past, and that the gaps that existed in the past were magnified during the pandemic. And so we have work to do in order to get students back where they need to be. Social emotional learning is more important probably than we ever thought. And many students suffered as a result of months and months of online learning. And then finally, educators, family members, and students are exhausted from the whole experience, and are needing a rest and also needing a way to go forward. So here we are after 15 months, and we are all looking for solutions. We're wondering, what can we do in order to address what's happened, but then also how can we be prepared for when something like this happens again, and also what lessons are there for us, so that we can develop an education system that our children so desperately deserve. Now, we do have a number of frameworks which are at our disposal, and which many people are looking to as a way to respond to the pandemic. So many are looking at culturally responsive education, the investments in what we know about multi-tiered systems of support in response to intervention, social emotional learning. Many schools and educators are looking to these frameworks as ways to actually move forward. We also have tools that enable us to think about how to go about doing it. Implementation science provides a framework about how to actually get from one place to another to a better system, and creates measurement systems. Improvement science has an iterative approach using plan, study, do, study, act cycles to iteratively improve. And then we also do have evidence-based practices which work for many students, and we also have high leverage practices. So what I want to talk about, in addition to all of those, is universal design for learning. So what we have learned is that UDL is about variability, and the pandemic illustrated how variable students are and environments are, and how the interaction between them creates challenges and opportunities. It's important to know that the pandemic really showed that there are barriers to positive educational experiences that we had not really paid attention to before, particularly around race and equity. So universal design for learning, many of you have probably seen the framework, but it's based on neuroscience and based on the three networks in the brain. The part of the brain which is associated with motivation and engagement, the part of the brain which takes in information for representation, and the part of the brain, the strategic network, which governs action and expression. Within these principles, we have guidelines which go from access, leading to higher order thinking skills, and ultimately leading to the constant thing that we really want, which are expert learners. That means learners who are self-motivated, who know what they want to learn, who are resourceful, and they are strategic and goal-directed. So what we're gonna share with you for the rest of the session are 3 UDL technologies that we have been developing at CAST, and each of them are built upon universal design for learning. Each of them work very well in face-to-face settings, but they also work in hybrid settings and online settings. And now we have a brief presentation about each one of those. The first one is Corgi, and Anne-Marie Kanoki is going to share information about that. Thanks for listening.
Hello, my name is Anne-Marie Kanoki, and I'm a project manager and a researcher at CAST. Today I'm going to introduce you to a program called Corgi. In partnership with the University of Kansas, we have created Corgi, an innovative suite of tools that marks the next generation of information and graphic organizers. We know and understand that higher order thinking is an important skill for all students, including students with disabilities, to be successful. Corgi supports students to co-organize and organize their learning by engaging with graphic organizers in a digital, flexible Google app environment that can be integrated into any learning environment. Research shows that Corgi works. Both our pilot study and independent evaluation of the Corgi app showed very positive results. Students made significant gains learning science and U.S. history content when using Corgi. Encouragingly, students with disabilities made substantial improvements in the independent evaluation. Corgi builds upon the research of the strategic instruction model from the University of Kansas to offer a new tool that makes graphic organizers more flexible and accessible. The Corgi process supports students to develop content-specific practices and habits of minds by exploring a topic guided by your essential question, organizing your information with the Corgi guide step by step, digging deep into the information and making sense of your learning, and sharing your learning through a variety of output options. Corgi is built with Google technology. Just like Google Apps, multiple users can co-edit a Corgi guide together. Corgi connects directly to the Google Classroom so teachers can create assignments and students can submit their work right in the app. Learners can transform their completed Corgi guides into Google Slides presentations automatically. Some of the key features that set Corgi apart is that it supports real-time collaboration, embeds universal design for learning to reduce barriers and increase access, and provides multiple options for learners to interact with, express, and present their learning. Now that we know a little bit about Corgi, here's a video walking you through the application.
Let's take a look at the Corgi 2 application. I'm here at the Corgi login screen. You can access this from any browser at corgi2.cast.org, but we recommend Chrome for the best experience. You will need a Google account in order to use Corgi, so if you don't have one, you can make a free one at accounts.google.com. The first time you use Corgi with your Google account, you will need to authorize it. And essentially what that's doing is giving Corgi permission to save the files you create directly to your Google Drive. This also means that everything on Corgi is cloud-based and you can access it from any device with an internet connection. Let's go ahead and sign in. Here's the Corgi homepage. At the top, you'll see all of my recent guides, and below that you have the ability to create a new Corgi guide. So before I go any further, what exactly is a Corgi guide? Corgi guides are interactive, digital graphic organizers, and each one is based on a content enhancement routine from the strategic instruction model. Right now in Corgi, we have 3 guides available: the cause and effect, question exploration, and comparison. But more guides are in the works, so check back soon for those. In order to show you some of the new features in Corgi 2, let me start a new guide. The goal of the comparison guide is to support learners to compare 2 concepts in order to respond to an essential question. When you first begin a comparison, you'll see all the steps on the left-hand side, and a graphic representation of the entire organizer on the right. Let's begin by entering our essential question. This layout is new to Corgi 2 and is called Focus Mode. It allows students to see how the section that they're working on fits into the bigger picture, or if it's more beneficial to them, they can close the full guide and just concentrate on one step at a time, making the application more flexible for each individual. Another new feature that we've added for Corgi 2 is the ability to add images. So for example, when I add my concepts, I can also add an image of each one. If I select Add Image, you'll see I have a few different ways I can add one in. I can upload one from my computer or insert one from my Google Drive, or I can simply just search the web. Once I've found an image that works for my guide, I can add it in. Anytime I need to enter text into a text box, I have the opportunity to use the speech-to-text function. Coniferous trees have foliage all year round. Students can also access the Text Help toolbar to have any text on the page read aloud.
How are coniferous and deciduous trees different?
Students can also look up words with the dictionary.
Noun, the main organ of photosynthesis and transpiration in higher plants.
Or translate words and phrases into Spanish.
Conífero.
Another goal of each Corgi guide is to help students build their vocabulary around the concepts they're learning about. To do this, students can add key terms at each step. When I select key terms, I can add in a word or phrase as well as the definition. After I've completed this step, I can check my progress by reviewing the full guide and see that all the information I've entered is visible here. After completing my comparison guide step by step, I can access the full organizer to review my work. We've built in a review checklist so students can see if there are any steps that they haven't yet completed and they need to go back and finish. To provide students with a way to present their work, we've created a presentation builder. All of the information and images that students have entered into their guides will be automatically transferred into a Google Slide presentation. Let's take a look. Students can edit and customize their presentation and even change the theme. We're excited about the potential that Corgi has shown to help students build higher order thinking skills and become expert learners. Thanks for checking out Corgi 2. We hope you get a chance to use it with your students in your classroom. And if you're interested in working with us, please get in touch. Email us at corgi@cas.org.
Hello, I'm Tracy Hall. I'm here to tell you about our project called Snoodle. Our goal in this project is to investigate what teachers and their students, including students with disabilities, need to meet growing accountability standards in science. At CAST, we work directly with teachers and their students to identify and create effective and successful science instruction when applying the scientific inquiry process. Snoodle is an acronym that stands for Science Notebook in a Universally Designed for Learning Environment. In the U.S., our stats on science performance in schools are unacceptably poor. International rankings at the high school level are very low. Out of 71 countries, the U.S. is 24th. Elementary performance is at or below basic, and students with disabilities of all grade levels is at or below basic. What is unique about Snoodle is how the tool provides supports for students and teachers in building sense-making skills in science. The ultimate goal of Snoodle is to support learners in making sense of concepts and to support learners to build connections with scientific principles and practices. Our focus in this current Snoodle work is at the 4th grade level. Our work is based on a line of research which resulted in improved science content learning as compared with traditional paper and pencil science notebooks. It positively impacted students' performance to the same degree, regardless of reading and writing proficiency, and increased student motivation for science learning. The more students created science explanations, the more they improved, and their higher motivation for science learning. For all students, especially those with disabilities, Snoodle provides learners with engaging, easily navigated, and scaffolded environment. Snoodle makes the steps of the science inquiry process transparent by chunking it into clear, manageable steps. Here you see the 6 pages in the Snoodle Science Notebook that reflect those steps. The focus question of the investigation, the collection of data, analyzing that data, and then providing an explanation for their results. Students then reflect and make connections of those science concepts to larger science concepts. And finally, the display page. This page shows the work that students have done in summary. This chunking process guides students through the science inquiry process and supports them to build science explanations and making connections with larger science concepts. In each of these steps, students have optional, on-demand supports for access and tools to support multiple means of expression, to demonstrate their understanding and build their sense-making skills in science. Accessibility is an absolute priority in our work at CAST. Here are some accessibility features in Snoodle. There are options for responding, including keyboarding, speech-to-text, drawing with annotations or descriptions, and uploading images or files. The entire tool includes text-to-speech for any text on the screen, as well as language translation. Supports and features. Highlights of these include automatic feedback on the use of science vocabulary words, which are then highlighted in the student responses, and a star appears in the Use These Words list to the side. Snoodle also contains sentence starters, checkpoints, as well as a pop-up view of previous pages to support working memory, and students have access to all the teacher feedback. We also focus on means to support elementary teachers in instruction for science and the use of science notebooks. Here you can see a few of our supports, including multiple ways to obtain views of student work, a system to monitor and provide feedback for students, a check-in overview page for each investigation with live updates for teachers. Additionally, teachers may edit as well as create investigations in Snoodle to meet the needs of their students. This project is a team effort, so now we'll hear from some of our team about Snoodle, our goals, and the development.
Snoodle, a digital science notebook in a universal design for learning environment. Snoodle is a flexible science notebook created to support inquiry science learning in order to build sense-making skills in science. Built on the principles of universal design for learning, Snoodle supports students by breaking the science inquiry process into clear, manageable steps. A primary goal was to make sure Snoodle is accessible to all learners. So we built it to be screen reader friendly and keyboard navigable. In each step of the process, students have optional on-demand supports for access and features to support multiple means of expression as they demonstrate their understanding and build their sense-making skills in science. Students may use built-in text-to-speech as well as speech-to-text options when responding in Snoodle. They also have the option to respond by creating a drawing and annotating their response, or to upload an image of their work. Snoodle supports students within each step to make connections with the focus question and big science ideas. All students' responses have supports. Here you can see sentence starters and hints we call "Did you?" that help students in their self-regulation strategies. Snoodle also contains motivating vocabulary supports. Not only do students have access to the meanings of these words, when they use these words on the page in Snoodle, the word is highlighted in their response, and the students get the word start. Snoodle guides students to move beyond doing experiments. Students are supported in how to analyze their data through questions and to build explanations. Here, students respond to 3 questions about their science investigation using the structure of claim, evidence, and reasoning to make sense of the science concepts and the experiment. This step, Reflect and Connect, supports students in making connections to larger science concepts and to reflect on how their learning is changing. Students have the option of responding to one of 4 questions to connect their experiences and understandings of science concepts and reflect on their ideas in science. Snoodle supports teachers too. It supports teachers to build investigations to meet the needs of students in their class. Teachers may build from a library of investigations in Snoodle or create their own using a supported template environment in the Snoodle tool. Using Snoodle has helped build elementary teachers' skills in science and their own science understanding, making it easier for teachers to focus on and support students in their classroom and build community. What are the results? In our pilot study, results show that the more students use Snoodle, the more all students, including students with disabilities, performed like their high-performing peers. And in our efficacy trial, results showed that the more students used Snoodle, the more they made connections with the big science ideas and built sense-making skills in science. Dive in to see what you can discover about Snoodle and how Snoodle can inform teaching and learning for all students. To explore in Snoodle as a student, go to snoodle.cast.org and use the username CEC_S2 and password 1234, all lowercase. To explore Snoodle as a teacher, go to snoodle.cast.org and the username CEC_T2 with password 1234. Interested in learning more? Contact Tracy Hall at thall@cast.org.
Hello, I'm Boris Goldowski. I'm the Principal Investigator for the Center on Inclusive Software for Learning, which we like to call CISL. So what's it all about? CISL is an attempt to make good on the promise of digital materials for enhancing educational outcomes for students with disabilities by creating some innovative software tools to interact with digital content. So accessibility here is essential, but it's not the only goal. We want to see an impact on learning outcomes for students across the spectrum of disability and beyond. We also want to make sure our approaches are documented and open so that others can adopt and build on them. The CISL Center has developed a reading and learning environment called Clusive, which is freely available at clusive.cast.org. And all of the code for Clusive is also open source. We want to collaborate with other developers of e-readers and publishers of ebooks to encourage everyone to build with accessibility, adaptivity, and universal design for learning in mind. Let's take a quick tour of some of Clusive's features. This is the video we go here. Okay, let's dive into some of Clusive's features in more detail. Clusive starts by being a library of classroom-ready content, which is presented in an accessible and supportive environment. We've imported over 200 texts of widely varying types. There are, for example, picture books from Tar Heel Reader. There's some short nonfiction on current issues from SERP's Word Generation curriculum. There's some classic literature, and we've recently been adding the exemplar texts from the Common Core English Language Arts and Social Studies standards. So soon our library will include all of the grade 4 to 12 exemplars which are available in the public domain. We've created accessible versions of these if we couldn't find them, and enhanced our library text by creating multiple reading levels and adding customized glossaries with images. Users can also upload their own content. Inclusive allows students to read in ways that are comfortable for them through an extensive set of user preferences. All the content can be adjusted in multiple ways. The font size, color, spacing, type of page navigation, and more. It can all be read aloud, and it can be marked up by the student with highlights and notes. But more than just customizable, we want Inclusive to be an adaptive learning environment. And we want to support adaptivity in a way that's consistent with universal design for learning. So we're not trying to do everything for students, but rather help students to explore and start to understand the ways in which they learn best. We consider adaptivity as a scaffold, not an endpoint. One example of this is our adaptive vocabulary support. So what is that? We ask students about their level of knowledge of words, as you saw in the demo video, and the system will remember this. It also tracks students' interest in specific words via their actions, like looking things up in the dictionary. So we can use this information about a student's knowledge and engagement to customize the display. So which words are underlined and linked to their definitions is going to be different for each student. And students can transparently view and adjust the stored data in the Word Bank page. We also have adaptive reading levels. So if a text has multiple reading levels, the system can recommend one based on the student's vocabulary knowledge. But the student can also make their own choice and explore the other versions whenever they like. The alternate versions of text are currently manually created, but we're looking into ways to offer similar functionality in a more scalable and automatic way. There are a lot of other personal touches that you'd find inclusive. So if you haven't used some key support features in a while, you might see a reminder to try them out. And as you read, we encourage you to stop, think, and to react. The student reactions are summarized on the teacher dashboard, and teachers can also upload their own content and share it with their classes. Inclusive was publicly launched this spring, and we're growing the user base with various activities like the Summer Reading Challenge, which just started up. So I encourage you to go check that out. You can access Inclusive and create your own account, or encourage your friends and teachers you may know to do so at inclusive.cast.org, or visit our project website at sizzle.cast.org. Thank you.
Inclusive, a customizable learning environment that adapts to you.
I use Inclusive because I get to read the way I want.
I use Inclusive because I can keep my notes and highlights in one place.
Learn more about topics.
Inclusive helps me use different tools and settings that work for me.
Welcome to Inclusive. Check out your recent activity, then head to the library to find something you like. Inclusive will make a recommendation for your just right challenge level, but you can switch it up anytime. Try the Read Aloud feature.
White, floating eyes in a dark blue ocean stretches as far as you can see.
You can set up Inclusive any way you want it, by customizing how it looks and how it works for different situations. Try the vocabulary support when you're learning about something new. As you use Inclusive, you'll learn more about your strengths and areas where you can build skills, so you can take charge of your own learning. With over 100 items in the library, you're sure to find your next great read. For more information, contact us at the Center on Inclusive Software for Learning, sizzle@cast.org.
Thank you so much for tuning in. We really appreciate the time you took to look at our video and look at our projects and our technologies. And we really hope that you have a great rest of your conference. Thanks.